Okay, so today we're going to talk about classifying types of solutions, so classifying systems of linear equations from graphs. So there are three types of solutions that we can come across. You can see there's a lot of labels up at the top here. So the first one we come across is what's called inconsistent. And that's when we have two parallel lines that never cross. So the two lines are not consistent with each other. They never actually interact with each other, right? That's what parallel means. So this means that there are no solutions, because a solution to an equation or system of equations is where they actually cross. So if they never cross, hopefully that makes sense, there are no solutions. So again, we call that inconsistent because they're parallel. They're not consistent with each other. They never actually interact, which means no solution. All right, so the second two have this consistent title at the top. So hopefully we understand if inconsistent means that they never interact with each other, they don't cross. Consistent means they are going to cross. And we have two options here. We have what's called independent or dependent. So independent lines are two different lines, completely different lines going in completely different directions. So I have a negative slope here and I have a positive slope here on the blue one. So this is where they have an intersection, one point where they actually cross. So they are consistent, they do cross, but they only cross at this one exact point. So there is one solution here. Dependent means that they're actually the same exact line. So we only see one color here, but it's because this red or orange, whatever color that is laying right on top of the blue line. So they are the exact same line. So usually you'll see this where it'll say like L1 and L2. You'll actually see the little labels on it. For this graphic, for whatever reason, we don't see that. But it just means that it's the exact same line when you graph them. So they have the exact same y-intercept, the exact same slope, and they lie on top of each other. So this means that we have infinitely many solutions because they don't cross at one point, they cross at any point at all. Any point that I choose on the red orangish line there is going to also be on the blue line that's underneath it, right? So any point on either line is a solution to both lines. So infinitely many solutions are possible, not just one. So again, inconsistent means they don't interact with each other. They're parallel, so no solutions. Consistent means they do interact with each other. They cross at some point, at least one, or all of them. And so independent means two completely different lines. Dependent means the same line. So hopefully just kind of thinking through that vocabulary will help you understand how we classify these lines. So let's go ahead and practice this. So we have system A, B, and C. We're going to look at them separately. They do give you the equations. They also give you the visual, which is really nice. You can do this off of the equation. You can do this off of the visual. As long as you have it in slope-intercept form, so you may have to convert this one that's in standard form to slope-intercept form, which is that y equals mx plus b that we've practiced. You can definitely take a look and say, does it have the same y-intercept? Does it have the same slope? If it doesn't have the same y-intercept, then they start at different points on the graph. And then if they have the same slope, then they'll be parallel. If they don't have the same slope, then they will eventually cross at some point. If everything is exactly the same, y-intercept and slope, well, that means they are the same line, right? So we can definitely do that from the equation, but hey, they give us the visual, so we can match it from the visual. So I can see this one. You can see the labels that I was talking about, L1 and L2. So I only see one line, but that's because L1 is lying directly underneath L2, meaning line 1 and line 2. So this is that idea. They're consistent because they do interact with each other, right? So I know they're consistent, but they're going to be dependent because they are exactly the same line. One lies right on top of the other. I only see one line, right? So they're consistent and dependent, and this means that they have infinitely many solutions. So I'm just going back through that vocabulary and matching. All right, so on this one, I can see line 1 and line 2. They are different lines. I'm showing you really quick that you can put it in slope-intercept form so you can see that. Y equals x plus 3, y equals x plus 3. They are, in fact, the exact same line. So now if we look at system B, I have line 1 and I have line 2. They are completely different lines going in different directions. I have a positive slope on line 2. I have a negative slope on line 1. And they cross at this one point. So they do interact with each other. They're crossing, so that makes them consistent. And since they're completely different lines, they're independent of each other. So they're consistent, independent. and this means that they're going to have one unique solution, that one spot where they cross. So I just need to identify that because it's asking me to here. I don't have to identify it over here, right? I just bubble in one of them that works. I only have to fill this in if I'm choosing a unique solution, so meaning one solution. So I can see that that's 3, -3. All right, the last one here, we can see again, we have line 1. Oh, I'm again looking at the slopes here. So you can see they do have different y-intercepts, but the slopes are opposites of each other. In this case, it's -2 and then 1/2. That actually means that they are perpendicular, which we'll practice, at some point here. We may practice it a little bit in semester 1, but these are actually perpendicular lines because the slopes are negative reciprocals of each other. All right, so now I have line 1 and line 2 here. So these are completely different lines, but they're going in exactly the same direction. So these are not consistent, meaning they do not interact with each other. They do look parallel. So they are inconsistent because they're never going to cross. So that means they are never going to have a solution. And I, again, can take a look at the slopes. They have different y-intercepts, and I can see that they cross the y-intercept at a different place. But up here, I have -2 and -2 for my slope. They have the exact same slope, which means they're dropping at the exact same rate, and so they're never going to come together. So that's classifying linear equations, and I hope that helped. I will see you in the next video.